Hello, and welcome to Possible Learning. This unit introduces ideas of logic, a topic which is the foundation of all mathematics. We will be looking at logic puzzles and introducing some work on sets. Here we look at set notation. We use this symbol epsilon to denote the universal set. This symbol is used to show the intersection of some sets. Another symbol to show the union of some sets. A dash will show the complement of a set. This symbol is showing a subset, and finally this symbol is showing the empty set. Example number 1. Our universal set is the numbers 1, 2, 3, 4, 5 and 6. Set A is the numbers 1, 2, 3 and 4, and set B is the numbers 4 and 5. We need to find for part A the intersection of A and B. For part B, we need to find the union of A and B. Part C is the complement of A. Part D is the complement of B. And finally, is B a subset of A? Part A, the intersection of A and B. When we're talking about an intersection, it's going to be this area where our two sets overlap. The intersection of A and B is 4. 4 is the only number that is in the middle where set A and B overlap. Part B, the union of A and B. So this means that it can be in set A or set B. And what we want is the whole area that A and B take up. So all of the numbers within set A or set B. And that will be the numbers 1, 2, 3, 4 and 5. It's all of the numbers in set A or B. Part C, the complement of A. We want the numbers not in A. So we could have 5 or 6. So the complement of A is 5 or 6. Part D, the complement of B. Similar to part C, only we're talking about B instead of A this time. So we want the numbers not in B. So B is this circle here on our Venn diagram. And the numbers not in B are 1, 2, 3 and 6. The complement of B equals 1, 2, 3 and 6. And finally, is B a subset of A? And what that means is, do all of the numbers in B belong inside set A as well? And we can see that 5 is in B, but it's not in A, so it cannot be a subset of A. Example number 2. Use set notation to describe the shaded regions of these diagrams. Diagram for part A, diagram for part B. So on part A, if we look at the part that's shaded, is going to be this bit here. So it's looking as though it's part of set B, but not all of set B, because this part, the intersection, is not shaded. What we can say is this shaded part is B, but not A. So we're using set B, but we cannot use the part of set A. When we're describing the part that is not set A, we can say that that is the complement of set A. So we want set B and the complement of set A. And we can see we've got set B and the complement of A. Diagram for part B. This time, our shaded region is looking as though it belongs to set A. But we cannot have set C or set B. That's going to look like set A and not set B or set C. When we're looking at these symbols, we can translate those into the words and for intersection and this symbol can be translated as OR. Translating this set of symbols then, it says set A and, here we've got brackets and that means not, so set A and not B or C. Example number 3. On this diagram, shade the region that represents, and this here. We've got our Venn diagram on the right hand side and we need to shade it according to this set of instructions. So what do these instructions mean? So we've got here the union, which we can translate as or, and here we've got the intersection, which we can translate as and. Inside the brackets we've got set A or set B. That would look like all of set A and all of set B shaded, and not set C. So we can't include anything from set C. Overall, that's going to look like this area shaded here. Not including set C, but using all of set A and B. We want the union of set A and B, which is not in C. That's it for the examples. On the next slide is going to be some questions. I'll leave them on for a few seconds, so you're going to have to pause the screen while you have a go, and press play when you're ready to move on. That's it for the questions. On the next slide is going to be the answers. That's it for this video. Thank you for watching.